Hello everybody and welcome to a chat from the engineering desk. Today we are going to be covering the OLED display, which is displaying temperature read back from the Dallas DS18B20 sensor, which I've got wired up over here. So that's it over there. Okay. There you go. Got it wired up. Let's put it back where you can see it. Now I've got it wired to an Arduino Uno. And then we've got the OLED display. So if I reset the display, the Uno briefly shows a startup screen, and then it shows a temperature. Then if I put my finger on the sensor, you can see the temperature going up. Like that. Okay. Put that back where you can see it. Wiring. We've got our supply over here. We've got I2C going to the display from the A4 and A5. Then for the temperature sensor, we've got one wire which is from pin 2 on the Arduino going to the data pin on the temperature sensor. So it's a very simple setup wiring wise. As you can see, as it writes to the display, that's slow. It's because this is a display, it's a graphic display, which means that the Uno is having to do quite a bit of processing and then write each pixel at a time, which is why you can see a delay. If you had it on a faster processor, this over here would happen quicker. But it works and it's nice. It's a very accurate sensor. It's a high resolution sensor. So it's displaying the temperature to within 1/10 of a degree C. Right, let's have a look at the code. The code's pretty straightforward. Let's move over to the computer side of things. Here we have the code. Bear with me for a moment. I need my circle so you can see where I'm pointing. That's better. Hope you can see that all right. So the libraries. This is the display sensor libraries. We started that first, SPI, wire.h, the Adafruit library, which is basically the graphics drivers library. And then the library for the SSD1306, which is our little sensor over there. It is the and then we do the reset. For the temperature sensor, we need one wire.h and Dallas temperature.h. We tell it that the temperature sensor is connected to pin 2 on the Uno. The one wire bus is the instance that we set up, and then we pass on the reference for the library over here. Let's look at the setup. I'll start with the display first. So that's the address for the display over there. It's a 128 by 32 display. There's a startup display that I display. Then after a second I wipe that clean and I increase the text size. Then sensors begin starts a library for the temperature sensor. Now what happens after that is very simple. I request temperature and we read the temperature into my variable temp C over there. We set the physical place where we want to display the temperature on the display. So the vertical is the first one, and the horizontal is the first number, it's 0, and then 10 pixels down, because we're wanting to display it in the middle of the screen on the blue pixels, and we display that variable that we read in over there. I then need to show some text after that, so it's 10 pixels down and 65 pixels across. I say degrees C. We then write all of this to the display by saying display. I then wait a second, clear the display, we read the sensor again, and then write to the display again. That's what's going on over here. So if I were to reduce this time to half a second, you'd see less of a delay while it's blank. Let's see what it does. Start up screen. So that's what the effect of changing that delay is. Now obviously one could do timing differently and so on. The delays are a quick and easy way to do timing on Arduino. Works for some things, doesn't work for other things, especially if you have to do housekeeping while there's timing taking place. Then you can't have a delay because your program obviously sits at this point and does nothing, so no other tasks get executed or any code. So you just got to be careful about that. And that's the extent of the code. Nice and simple. It's a nice little display, that useful. You can add it to a project if you want to display some stuff. It's nice and small. Just be aware that it takes quite a bit of processing to use one of these displays, and quite a bit of program code. We've used up 52% of program memory on the Arduino with that. The temperature sensor uses about 10% and the display uses about 40%, so it adds up to about 52%. It uses up a lot of space, so just be aware of that. If you wanted to avoid that, you could perhaps use an I2C LCD instead to display the temperature, or write it out to serial. Whatever it is you're wanting to do, it's your project. But here's an idea for a project. You could do this. Very nice. And that pretty much concludes our talk on the little sensor and the display. I had a request to talk about the display, so there it is. Hope you enjoyed it, found it interesting, learned something from it. You're welcome to comment down below in the chat. You're welcome to subscribe, hit the bell notification, and come and visit for more videos as they come out. For the rest, have an awesome day further, folks. I'll see you for more. Cheers.